Hey Amy, so for this week, what we are going to do is we are going to finish the reading on lesson 15. Um, if you remember, I italicized all the paragraphs that we want to work on for this upcoming week. And then when we are done with that, we are going to do the whole reading for the entire article. Now we've had a few weeks to work on this, and if time allows, after we finish this, I have selected one more article that we will be doing a cold reading of, meaning that we haven't seen this article before. If we have time, we'll see it on Wednesday. So, just to kind of give you a little help on it, I'm going to read the first couple paragraphs of the italicized um, paragraphs that I wanted you to work on for last week. We weren't able to meet last week, but now we want to work on this. So, what we lose might be lost forever, Winckelmann says. There are other possible feedback mechanisms, both positive and negative, that weren't included in the simulation, Winckelmann adds, either because the mechanisms are negligible or because their impacts aren't yet well understood. These include interactions with the ocean climate patterns such as the El Nino Southern Oscillation and with ocean circulation patterns including the Atlantic Meridional Overturning Circulation. It's basically the flipping of hot water and cold water. Previous research suggested that meltwater from the Greenland and Antarctic ice sheets may also play complicated feedback roles. Nicholas Gullidge, a climate scientist with Victoria University and of Wellington in New Zealand, reported in Nature in 2019 that that flows of Greenland meltwater can slow ocean circulation in the Atlantic, while cold, fresh Antarctic meltwater can act like a seal on the surface ocean around the continent, trapping warmer, saltier waters below, where they can continue to eat away at the underbelly of the glaciers. In a separate study published September 23rd in Science Advances, Sheena Sadeh, a climate scientist with the University of Massachusetts Amherst, and her colleagues also examined the impact of Antarctic meltwater. In simulations that look out to the year 2250, the researchers found that in addition to a cool meltwater layer trapping warm water below it, the surface layer of fresh water would exert a strong cooling effect that could boost the volume of sea ice around Antarctica, which would in turn also keep the air there colder. So those are the first couple paragraphs. Remember to read these out loud to yourself. If need be, read along with me these first couple paragraphs. I read them nice and slow, and that'll help us with the more complicated words in here, like Massachusetts Amherst, the El Nino Southern Oscillation, and the Atlantic Meridional Overturning Circulation. Those can be very complicated words to pronounce. So when we work on these, go ahead and say these out loud, because there's no practice like physically saying these words out loud. So if you have any questions, go ahead, email me. We'll see you on Thursday.